This is Pre-Calc Section 6.5, Part 2. In Part 1, we learned how to evaluate determinants. In Part 2 here, we're going to use what's called Cramer's rule, which is a method for solving a system of equations using those determinants we just learned how to do. For Cramer's rule, you want to take this matrix right here, ignore the constant column for right now, and I'm going to call this the D matrix, and that's 3, 2, negative 4, 5. That is the D matrix. I need to construct something called the dx matrix and the dy matrix. And they're very easy to make. What you want to do is take these answers and put them in for the x column coefficients to find the dx matrix. So the dx matrix will be negative 1, 7, but the rest of the column will be what it was right here, negative 4, 5. Then I want to take those answers, that constant column, and put them in here. So the beginning of the matrix will be 3, 2, and the constants will go in the y column. The way you can remember this is this. We're going to use these constants to help us find the answers for x and for y. So to find your answers for x, you're going to put them in the x column. To find the answer for y, you will put them in the y column. So those are your three matrices. Very important to put this in the proper order. This is your constants. This was your old y. This was your old x, and these are the constants. That's how we set this up. Then we're going to evaluate the determinant of each of these. The determinant of this is just 15 minus negative 8, which is 23. And here's something that's very important. If the determinant equals 0, we cannot continue with matrices. We'll have to talk about that in a minute. So you always want to figure out the D matrix first. The D is 23, so that says go ahead and continue. Get the dx, get the determinant of this. This is negative 1 times 5 is negative 5, minus, multiply up, negative 28, minus a minus is plus, gives me 23. And dy, 3 times 7 is 21, minus, multiply up, negative 2, minus a minus gives me 23. Then you do something very easy to get your x and your y. It will be dx over d, and to find y, it will be dy over d. So I just have to fill in, dx is 23, d is 23, 23 divided by 23 is 1. Over here, same thing happens, 23 divided by 23 is 1. That makes my ordered pair 1, 1. So once you have your matrices set up, all you are doing is evaluating three simple 2 by 2 matrices determinant. So you can check also by plugging 1 in for x, 1 in for y in both these equations, and they both check. Two comments about Cramer's rule. One is there's some things in physics where you're going to set up matrices, but you only need to find either the x value or just the y value, or maybe just the z value when we finally get to 3 by 3. And instead of having to go through the whole process and solve the whole system, you can use Cramer's rule to just find x, or just find y, or just find z. So that's one real good benefit for Cramer's rule. The other benefit is if your answers are fractions, you're not having to plug fractions back in and do the arithmetic to find the other one. So let's look at another one. First thing, get your D matrix from these coefficients. So D is 3, 2, 2, negative 1. dx is where we put the constant column in place of the original x column. So it's negative 4, negative 5. But then we put the original y values in their position. dy, we will put the constant column in the y position. So negative 4, negative 5 will be over here. And we go back to the original values in the x position. Evaluate those determinants. 3 times negative 1 is negative 3. Minus 2 times 2 is 4, gives me negative 7. So d is not equal to 0. That says continue. This dx, negative 4 times negative 1 is 4, minus, multiply up, negative 10, minus a minus is plus, gives me 14. And on this one, 3 times negative 5 is negative 15 minus negative 8. Minus and minus goes to plus, which gives me negative 7. So your x value is dx over d, which is 14 over negative 7, which is negative 2. And your y value is dy over d, which is negative 7 over negative 7, which gives you a positive 1. Your ordered pair, negative 2, 1. You can plug those in for x and y, and you'll see that they do check. Now just pretend for a second that the d value had been 9, let's say. Well, you would have gotten a fraction answer for x very painlessly. You won't have to take that fraction and plug it back in to find the y value. That's what I meant by if your answer is going to turn out to be a fraction, you don't have to do any arithmetic to worry about that fraction. The fractions just appear at the end. So this was actually negative 7, and then we'll go to another one. Get your d, 3, 6, 2, 4, dx. Put your constant column into the x position. Your y column stays what it was originally. dy. Put your constants into the y position. So this is 4, 8, and the front stays 3, 6. Now we want to do the determinant. This is 12 minus 12, which gives me a d value of 0. So that says Cramer's rule is not going to help me. I need to complete this another way. I could go back to the very beginning and solve this system of equations using elimination if I wanted to, but I want you to think about something. As soon as you get d equals 0, that is telling you that it is either an inconsistent solution or it is a dependent solution. And an easy way to tell that is to go back and look at the ratios of the x's, the ratio of the y's, the ratios of the 4 and the 8. This will save you having to do a whole solve. So 3 over 6 is a half. 2 over 4 is a half. 4 over 8 is a half. If all three of those ratios are equal, that tells me that the system is dependent. Now I'm not finished, but at least I didn't have to take the time to solve for x or try to solve for y. Knowing that this system is dependent, I know I need to get a solution that will be something comma y. The reason it's something comma y is that MathLab is going to tell you to put your solution in terms of y. So we will go up to one of these, it doesn't matter which one, and rewrite it. So we have 3x plus 2y equals 4. We want to solve this for x. So 3x equals 4 minus 2y, and x equals 4/3 minus 2/3 y. Or I could have left it as 4 minus 2y all over 3. That might be easier to type into MathLab. That is my expression for x. So 4 minus 2y over 3. We've done these before using different methods, and what this is this is the generator that will give me all of the points that are solutions to this system. And why do we need to talk about this generator? It's just so that you understand when it works out this way that it's dependent, it is telling us that there are infinite points. Remember from previous sections, infinite points does not mean you get to just pick whatever random points you want and call them solutions. The solutions must be generated by these expressions. So you say, okay, let's say y is 0. I'm just making that up. If y is 0, put 0 in for both of those y's, then I know that my ordered pair, of course, ends with 0. Put 0 in for y, that all goes away, and that gives me 4/3 comma 0. That is one of the infinite solutions to this system. It is not the only one. It's an infinite set, but the whole set can only be generated by these expressions. One other comment, because I don't have an example like this in this video, is this. If you had done these ratios and had gotten, let's say, 1/2 equal to 1/2, not equal to 1/2, that tells you that there is no solution. It is not a dependent solution. What it is an inconsistent solution, because if you graph these lines, you would see that they are parallel. There's no point of intersection. So if you do the ratio thing, 1/2 equal to 1/2, not equal to 1/2. Of course, it's not always 1/2. I'm just saying that these numbers would be the same. If these two numbers are the same, but this third number is not equal to those, then you know it is a no solution.